In this lesson, we're going to focus on solving systems of equations by graphing. When you graph systems of equations, we're looking for one of three possible outcomes, and you'll see those on the screen. The one on the left in the blue, that's a consistent and independent situation where you have two lines that cross into a single point. That single point would be the solution for both equations, which means when you plug those numbers in, it gives you a true statement, and that once again is consistent and independent. A consistent and dependent situation occurs with the purple and green lines. That's where you have one line on top of the other, and that results in many or multiple or infinite, if you will, answers. So consistent and dependent has an infinite number of solution points. The last one is inconsistent. You see in black, that means we have two lines that are parallel. These lines never touch each other, and in that case there is no solution. So we have two lines, 3x minus 2y equals negative 6, x plus y equals negative 2, and we're going to graph both of these lines. We're going to use two different methods just to demonstrate how to graph a line. For the blue line, 3x minus 2y equals negative 6, we're going to use the x and y intercept. Remember, in the x and y intercept method, to find the x-intercept, we let y equal 0. So let's do that first. 3x minus 2 times 0 equals negative 6. So basically we've eliminated the y variable. 3x equals negative 6. Divide both sides by 3. X equals negative 2. So we have our first point, which is negative 2 comma 0, and this is for the blue line, the first part of the blue line. Remember, anytime you're graphing, you have to have at least 2 points to graph a straight line. Now let's find the y-intercept, so we let x equal 0. So 3 times 0 minus 2y equals negative 6. So we have eliminated the x variable. Divide both sides by 2, or negative 2, excuse me. Y is equal to positive 3. So our second point is 0 comma 3. So we can plot both of these points on the graph. 0 comma 3, let's do this in blue. 0 comma 3 is here on the y-axis, negative 2, 0 is on the x-axis, and we draw a line between these 2 points. We have the blue line graphed. Now we need to do the red line. In doing the red line, since we have a coefficient of 1 on the y, that makes it very easy for us to put it in y equals mx plus b. So let's take this line, x plus y equals negative 2, and let's use the slope-intercept form. So let's solve for y. So that means we have to subtract x from both sides of the equation. So y is equal to minus x minus 2. What this gives us is two pieces of information. The first thing is the y-intercept, and that's at the negative 2 point, so that would be 0, negative 2. And then we also know the slope of the line, and that's the coefficient of the x, so that's going to be negative 1. And don't forget, anytime you have a whole number or integer, that's always over 1, so that you can do your rise over run. So we go to negative 2 on the y-axis, so 0, negative 2, plot that point, and we do a negative 1 slope, which means we go down 1 unit first, and then always go to the right. So it's down 1 and then to the right 1. So now we have our 2 points. We can now draw a line between those two, and let's extend it to see if this graph, our 2 lines actually cross each other. In this case, yes, they do. They cross at this point I've just labeled in green. And what point is that? That's negative 2 comma 0. So since these two lines cross into one point, we say they are consistent and independent. And the solution for these two equations is the point negative 2, 0.